in this section we are going to discuss about the plane section of a sphere. Now I am going to consider a sphere. This is a plane. So I am going to cut that sphere by the plane, then I got a section as a circle, right? So here you see that this is also circle. I am going to consider this is a sphere. This is the center of that sphere. Now I am going to cut that sphere by the plane. Then I got a section that is, it is a circle, right? Just to see the concept of this problem, right? How to solve the problems. The equation of the plane and sphere, right? What is given here? They will give a equation of a plane and equation of sphere, right? So two things are given. So they will ask to find center of a section, right? That is center of a section. Here we get the section as a circle, right? So the center of the circle we have to find now. So the solution for this problem, how do you solve the this kind of problem, right? So the point of intersection of the plane and the normal to the plane through the center of a sphere, that is our center of a section, right? You see, this is a sphere, this is the center of a sphere, right? The question is find the center of the section. So this is the circle I got, right? So the center of this circle is this, right? I'm going to give that name as the coordinate as Q. Center of a sphere is C, and that this point is considered as a point P, right? So the point of intersection of the normal to this plane, right? The point of intersection of normal to this plane and the given plane, right? We get that point of intersection. So that is our center of a section, right? So this is our normal to the plane, right? So this is a given plane, right? So how do you find the radius here? So here the distance between C and P, this is our radius of sphere, and this is the distance from Q to P is our radius of circle. This is our required value, Q to P. And find the center and radius of the circle. X square plus y square plus z square is equal to 9, x plus y plus z is equal to 3. This is equation of sphere, this is equation of plane. So two things are given. So we have to find center and radius of the circle, right? Equation of a sphere, x square plus y square plus z square equal to 9. This is equation of sphere. Here the center u, v, w all are 0, right? So the center is in origin, and the equation of plane. So this is equation of plane, x plus y plus z is equal to 3, right? So two things are given. So now the center of the sphere is origin. So then I am going to find the radius of the sphere. So root of u square plus v square plus w square minus d. Here u, v, w all are 0, and then I need to find the constant value. Plus 9, take it to the right hand side, left hand side. So I am getting minus 9. So minus into minus plus 9, square root of 9. I get the value is r is equal to 3. So this is radius of sphere, right? This is radius, the center of sphere. So but the question is find the center and the radius of the circle, right? Let the center of the circle be, I am going to consider the center of the circle, that is our point Q, right? So this is the sphere, the center of the sphere. This is center of the circle Q. This is the point on a sphere P, right? So this is right angle triangle. This is right angle, right? This is the right angle. So that now we see the solution for this problem. Right now the Q is x comma y comma z. Now Q is the foot of the perpendicular. The point Q is the foot of the perpendicular from C to the plane. So this is the foot of the perpendicular. This is foot of the perpendicular from C to this plane, right? Now, so I am going to find the foot of the perpendicular, that is the coordinate of Q, right? So the direction ratio of CQ. What is the direction ratio of CQ? So CQ, already we know that the point C is in origin, that is 0, 0, 0. So the point Q is x, y, z. So the direction ratio of that CQ is x minus x1, y minus y1 and z minus z1, right? Here x1, y1, z1 is 0. So the direction ratio of the line CQ is x minus 0, y minus 0 and z minus 0. So that is we get x comma y comma z, right? The direction ratio of normal to the plane, right? So any normal to that plane, right? The normal to that plane, the equation of the plane. What is the equation of the plane? This is equation of the plane. The normal to the plane is what we get, the coefficient of x, coefficient of y, coefficient of z is the normal to the plane. So that is 1 comma 1 comma 1. That is the direction ratio of normal to the plane, right? So the direction ratio of normal to the plane is 1 comma 1 comma 1. So we got two direction ratios. One is CQ, right? One is CQ, that is direction ratio, right? Another one is normal to the plane, right? So both these are parallel, right? That here CQ is parallel to the normal to the plane, CQ. So this is CQ. So I am going to find that normal to that plane. So any normal, if I am going to consider any normal, so the normal and that CQ both are parallel. So the condition is already we know that two lines are parallel, then its direction ratio are proportional. So I am going to write it as in proportional form. So that is the value of x, that is the first direction ratio of CQ, that is x, y, z. So x by that value is 1. So x by 1 comma equal to y by 1 equal to z by 1, say some constant value. So from this the value of x, so x by 1 is equal to r. So I am getting x is equal to r. Y by 1 equal to r, then I get y equal to r. Z by 1 equal to r, then I get z equal to r, right? So that any point on CQ is of the form. So I am going to consider a line. So CQ, any point lie on this line is of the form r comma r comma r, right? R comma r comma r. So suppose that the point Q lie on this plane, any point lie on the CQ is of the form r comma r comma r. So I am going to consider this Q is lie on its plane. So this point must satisfy the equation of plane. So now I am going to substitute that value r comma r in equation of plane, right? So if this point lies on this plane, then x plus y plus z equal to 3, then I am going to substitute that values, that is x is equal to r, y equal to r, z equal to r. So r plus r is equal to 3. So I am getting the r value equal to 1. So there we get value of, that is the constant value is 1, right? Next, so the point Q is, already we know that what is Q. So r comma r, the value of r is 1 comma 1 comma 1. Now the center of the circle is, what is the center of the circle? The center of the circle is 1 comma 1 comma 1, because the center is our Q. The value of the coordinates of Q is 1 comma 1 comma 1. So that is our center. So one part of the question is over. So we have to find the radius, right? So for that purpose I am going to find the distance, that is the length of CQ. So we know that coordinate of C, we know the coordinate of Q. The coordinate of C is the center of a sphere. So that is 0 comma 0 comma 0. The coordinate of Q is 1 comma 1 comma 1. So just now we found that value. So now it's the distance between 2 points, right? So now substitute that value. So I get 1 square plus 1 square plus 1 square, right? So I get square root of 3. So that is our CQ value. So this is the value of CQ, right? Already we know that what is CP. CP is the radius of sphere. So the length CP is a radius of sphere. So CP is equal to 3, right? Now we are going to find that radius of circle. So how do you find the radius of a circle? So here we are going to use that Pythagoras Theorem. So this is right angle. So that CP square is equal to CQ square plus QP square. From this I need to find the radius of the circle. The radius of the circle is QP, right? So the QP equal to radius of circle, QP equal to square root of CP square minus CQ square, right? Now square root of the value of CP square is 3 square 9, and CQ is our square root of 3. Now substitute that value here. Square root of 3 square becomes 3, right? So now find that value. Square root of 9 minus 6, I get a QP is equal to square root of 6. So this is our radius of circle, required circle. So this is the answer for this problem. So the question is find radius and center, right? You can try it, right? The question is find center, radius and area of a circle. Right, x square plus y square plus z square minus 2x minus 4y minus 6z minus 2 is equal to 0, x plus y 2y plus 2z equal to 20. So this is equation of sphere, this is equation of plane, right? So the answer for this question, the similar method you can apply. The center of the circle is 2, 4, 5 and the radius is square root of 7. You can verify it. So the another question is find the area of a circle. Area of a circle, already you know that pi r square, pi times radius square, radius of the circle is square root of 7. So I get 7 pi square units. So this is the area of a circle.